So this is where our trig ratios come into play. All right. So like I was saying earlier, trig ratios and Pythagoras theorem, those things go hand in hand whenever you think about a right angle triangle. So in this other question that I got here, notice we have two triangles back to back. But one of the things that should stand out to you almost immediately is the fact that we have a right angle forming at S. All right. So we have ourselves a right angle triangle. Now, remember, like I said earlier, visually, we might not be able to identify the longest side of a triangle simply because not all our diagrams are drawn to scale, especially in some of our geometry problems. That is very significant, okay? Now, let's say we have a question like this, and they're asking us, right? So you see all this little piece of information here that's just describing your diagram in words. So if words don't really get to you, like you don't understand it too well, and visually you understand what you're seeing in this diagram, you don't need to worry too much with the words. But if you're the type of person, visuals don't appeal to you and you don't understand visual diagrams, like how we have the triangle business going on here, read the information. All right, so the information says the diagram above shows triangle PQR, right? PQR. And they said not drawn to scale. So first of all, they're telling you that flat because they know how triangles operate. And we'll get to that shortly. PQ is 20 centimeters. PQ is 20 centimeters. This symbol here is one of the many different symbols that we use in geometry to represent angle. So when you see this, do not confuse it with less than. This is the angle symbol in geometry. So angle QPR is 30 degrees. QS is perpendicular to PR, and I said that word earlier, right? I said that word perpendicular earlier. Perpendicular means that the lines intersect at a 90-degree angle, which is the case that we see here, right? SR is 9 centimeters, so they told us the length of this side here, SR. And they also told us that angle SQR is X degrees. X degrees meaning we don't know the magnitude of it, all right? But we'll get there shortly. So the first thing they're asking us to do is calculate the length of QS. Now remember what I said earlier, not drawn to scale is there for a reason. Not just because they wanted to type and make your life hard. They put that there because they know that there are students who would think, oh, it's a diagram. I'm gonna take my ruler and measure it, right? It's not gonna work out because the diagram is not drawn to scale, right? So you can't measure the side and guess an answer and write it down. You have to use trigonometry to get your answer. So we're gonna get there in a little bit. Let me see what's going on in the chats. Very good. All right, so angles. Now you should know it means angles. You guess the answer. Oh my goodness. I hope your guess was very much you know, on the side of exactly multiple choice. The multiple choice, you'll have a 25% chance of guessing correctly. All right. So to be fair, like I would say, while that's your odds when you do study and you reach questions that you don't know the answer to, that's really and truly what it up to a chance. But if you learn, if you understand it inside out, if you do enough practice, when you see these things in multiple choice, you would not feel as intimidated by it, right? So that's why knowledge is power. Make sure you're familiar with your symbols. Make sure you're familiar with the, like I used to tell earlier, certain words that you'll hear in particular topics. Pay attention to those things, right? So now, like I said, the length of QS. You cannot take a ruler and measure it. Don't attempt. Do not. Once you see not drawn to scale, don't try, right? Don't try to guesstimate because you know that side looking like 20 and that piece looking like 9, and you have to use tricks. So here's how you're using your tricks. the first thing is we need to be familiar with our trig ratios. So can anybody tell me what are the trigonometric ratios? Right? What are the trigonometric ratios? There are three ratios in particular that we use. Oh, look at this. Beautiful. Sine, cosine, and tangent. Beautiful. Oh, your answer is so beautiful, Jahim. I love it. All right. So here we go. Sine. Sine is opposite over hypotenuse. He did it so well. So let me just write this out. Sine is opposite over hypotenuse, right? I just put in the first letter. Cosine is adjacent over hypotenuse. I put E instead of a H. Eraser. Right. Like I was saying, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. For us to be able to figure out how to apply our trig ratios, which one works best, which one doesn't, here's what we're going to do. Oh, all right. So here we go. So this question now, right? To get the length of QS, we're going to pay attention to the information given in the triangle. In our diagram, we could look at the right angle triangle that's forming PQS. And first off, remember what I told you all earlier? What we call the downhill side again? What's the name of the downhill side? Anybody remember what's the name of the downhill side? With an H. It starts with an H, Randy. Hi. There you go. Hypotenuse. Beautiful. All right. Randy, if you drink the monster, it's starting to kick in. That's good. That's good. Hi, beast. Right. So the downhill side is called the hypotenuse. And in this triangle, notice that that's information that they gave us, right? So we have the hypotenuse. All right. Now, QS. If we want to find QS, we need to figure out which side of the triangle QS is, right? And how we figure that out is based on the angle that we're given. Notice in this triangle, we have this angle here at 30 degrees, right? Right. So this is how you name the other sides. Hypotenuse is always fixed, it's opposite to the right angle. But the other two sides differ in the sense that it's dependent on the angle that you're looking at the triangle from, right? That's the best way I could put it for you to kind of visually identify the two of them, right? I used to confuse this a lot when I was in high school. It is something that I understand that can happen to a lot of students if they are not inclined in geometry, all right? So QS is the opposite. Beautiful. QS is the opposite. And the reason why it's called the opposite side in this particular scenario is because the side QS is opposite to the 30-degree angle. All right? It's opposite to the 30-degree angle. So if we were to shrink ourselves down onto the level of this diagram and look at the triangle look at QS in particular from the point P, basically QS would be opposite to us, right? And the adjacent side, right? The adjacent side, if we are familiar with the word adjacent from English, adjacent means that it's next to, all right? So the adjacent side is the side PS because it is right next to your angle 30 degrees. So your adjacent side is always next to the angle and your opposite side is always facing your angle. Okay, so which trig ratio should we apply? We apply the trig ratio which involves the side that we're given and the side that we want to find. So which side do we want to find? I can only remember the opposite to find all the sides because of the 30 degrees always opposites. All right, so technically I can show you coming from because sometimes the questions end up being like that most of the time, right? So very good. We're using the sign ratio. We have to use the sign ratio because we want to find the opposites and we are given the hypotenuse. So the sign ratio involves the opposite side and the hypotenuse, and this is the reason for choosing sign. So our working is going to look something like this. We'll start off by writing sine of the angle. So the angle that we're given in this case is 30 degrees. So we're going to put sine 30. All right, this is a proper way to use your trigonometric notations. So make sure that you write these things properly. All right, good. Now we're going to do the working. So the sine ratio is the opposite side over the hypotenuse, right? So sine 30 is opposite over hypotenuse. From here, what I'm going to do is substitute what I know into my ratio. So I know my angle is 30 degrees. I don't know the side QS, but I do know that QS is the opposite side. So I'm just going to replace the statement, the notation here in the statement, right? And the hypotenuse was given to us. What is the hypotenuse of the triangle? What am I going to replace the hypotenuse with? What value? 20. There we go. So in case you can't remember your working, this is what your working is going to look a little like. Now from here, we have to rely on our algebra skills. And the algebra skill we need here is the transposing skill. So what we're going to do is what people loosely refer to as cross multiplying, because you're going to multiply opposite side by opposite side like that, right? And when you quote unquote cross multiply, what you'll end up getting is a statement that says 20 sine 30 is equal to QS. Okay? So 20 sine 30 is QS. And when we work this out on the calculator, you should get 10, right? So you should get that the length of QS is 10 centimeters. So let's talk about your calculator usage where it concerns trigonometry. So for all of us, we should have a functioning scientific calculator, whether you work with the Sharp DL or you work with your Casio or you work with any of the others, right? Here's what you have to pay close attention to when you're using your calculator though. On your display, you usually see a few things when you switch on your calculator, right? For example, most times when you switch on your calculator, you'll see 0. But at the top, you will sometimes see some of the functions that the calculator is in. One of those things that you will want to look out for on your calculator display is DEG, which represents degree. All right. Aside from degree, you have radians and you have gradient. We wouldn't use gradient, right? We've never used gradient, but radian is particularly applicable to people who do art math, right? And even people who go on to sixth form. So we don't want our calculator to be in radian measure, nor gradient measure. We want it to be in degree. So you make sure at all times your calculator, when you're doing trigs, you see DEG. If you don't see DEG, you could just reset, or you look for a DGR button and you click it until you see DEG appear on your display. Why is that critical? If you were to calculate an angle in degrees versus radians or gradients, your answer is going to be completely different. So this is the reason why you want to make sure your calculator is always in the correct mode. So if you want to do sixth form, you have to do art math. Oh, no. Sixth form is if you decide to do pure math. The geometry and trigonometry is one of the modules in unit 1, right? And you usually use radian measure in sixth form and you use the radian measure in add math. Also, it depends. Remember again, like I say, it depends on your field. It depends on what you want to get into. And like I say, it's just like a heads up in case you're using your calculator and you see these things. They have a purpose, they have a function, but sometimes we're not interacting with it at the level that we're dealing with math, right? Yeah. In medicine, you'll be using more of your bio and your chem. You'll have some math here and there. But even if you go into sixth form, you don't have to do biochem math to get into med school. I know some people who did things like biochem phys and they went through just fine. But like I say, it's all dependent on what you get through to do at sixth form level. And I know a lot of people tend to run from pure math, but it was a nice subject. It was not too bad, right? So this is QS. QS is 10 centimeters, right? So if I were to ask you all to use your calculators, right, the working that you would have if you had to work out sine 30, you would, first of all, you would press sine, right? You look for your trig function buttons, you press sine, and then you enter the angle, and then you click equal, and you should get 0.5. Now, like I was saying, if you were to have it in any other mode, particularly when we want to calculate missing angles, that's where you have to pay attention to that degree, radian, or gradient mode, all right?